In this section, we're going to talk about linear arithmetic runtime algorithms. Most of the efficient sorting algorithms, such as quicksort, merge sort, both run in n-log-n. So we're going to focus on implement a merge sort and analyze its runtime. So let's start with implementation. So just to give an idea, merge sort is going to take an array. It's going to divide it in half each time. It's going to divide in half. Let's change the color so it's easier to see. It's going to divide it in half, and then this half is going to divide it again until it has actually only two elements. And then when it has two elements, it will sort them. Then it will divide this in half and it will sort them. And then yeah, it's gonna do that recursively. It's going to sort it, and then it starts to merge again all the elements. But it's going to merge it in a way that is sorted. So maybe it doesn't make too much sense, but we're going to go in depth what it's doing. So let's implement that. So we need two functions. One is called sort, another is merge. So let's start with sort, which is a recursive function. And it's going to split the array in half each time. A is the array. So if the array only has one element, we have nothing to do there. We just return the whole array. As it is, we don't have to sort them. It's just return that. However, if it has two elements, we can do something. We can merge two elements. It's very easy. We just need to compare if the first one is bigger than the second one, and we know it goes one way or the other. So in code, it will look something like this. So what it's doing is comparing. Let's say that you have two numbers here. You have 9, and you have 7. They're comparing if 9 is bigger than 7. Then you know that you should have 7 first and then 9. If it's the other case, let's say you have here 3 and 4. So 3 is bigger than 4? No. So this is the positive case and this is the negative case. So since it's not, you're gonna have exactly the same, 3 and 4. So this is solving for 2. And then the last case is for anything else. Let's scroll up a little bit. We have some more space. So for anything else, here's where comes the interesting part. We're going to use recursion. So we're going to return. So first, we're going to divide the array in half. Let's do that first. So let's call it half. Half is equal to, we're going to divide out. So we have length divided by 2. But we want the integer part. So we need parse int. You implement it in JavaScript. Right. Then you have length divided by 2. It's also a good practice to always use the base 10, right? So yeah, so we have the half element, and now we're going to do two things. We're going to return. So we're going to divide the array. We're going to divide the array recursively. We're going to do sort. Then we have the array A. We are going to slice it from the first element to a half without including the half part, right? And the second division will be sort from half, including the half part, until the end. So we can just leave it like that, right? So what we're gonna do with these two two parts, we're gonna merge them. So we are gonna have a new function called merge. It's gonna merge both sorted parts. Okay. So that's that. Right. So we have merge function. So we just implemented this sort part. So now let's do the merge function. Merge. So what it's gonna do is gonna take two pieces of the array, or two arrays for these purposes, and then it's going to merge them in ascending order in a new array. So let's call this so what do we have here? So we initialize, so we have the two arrays A and B. We start AI and BAI means the indexes on these arrays. So to give a better visual, let's do an example. Let's say A is equal to 3, 5, 7. And let's say B is equal to 2 and 4. So what it's gonna do, both of them are gonna start in index 0, right? And then we're going to go through all the numbers. They may have different lengths. We have 3 elements, 2 elements. We are going to go until all of them are finished. So we say AI is bigger than the length. So AI is starting 0 is bigger than 3. No. And is the first element 3 bigger than B, than the element in B, which is 2 in this case. It is. So what we're gonna push 2 to the new array. So this is merge. So 2 will come down and we will have 2. And then we increment the index in here and it will be pointing to 4. And then we go back to the loop. We go back to the loop. And then we say again, AI, which is 0, is bigger than 3. No. AI, which is 3, is bigger than 4 in this time, because this is pointing to 4. It is. 3 is bigger than 4. No, it's not. So it's gonna do the other case, which is A. So it's gonna take the element 3, right? And it's gonna advance to the next position. So it's pointing to 5 now. So what we're going to do now, we're going to do the same check. So if it's 5 bigger than 4, yes, it is. So we are gonna take whatever is in B, which is 4, and then we're going to advance it to the next index, which is the null element, right? So, okay, and then we're gonna go back and ask if it's bigger, if this one is bigger than, if AI is bigger than the length. It's not. And then if the element in here, which is now 5, is bigger than this element here. Okay, so which is not, because it has nothing. Okay, so now here is undefined. This one is undefined now. So it's 5 bigger than undefined. So when you have undefined, it's not bigger or small. So that will be always false when you compare. So it will go to A, and it's going to add 5 here. And the same will happen with the 7. It's going to add these two numbers. And then there we have it. We have the numbers 2, 3, 4, 5, 7, and they are sorted based on them. So what is the runtime of this? The runtime of this is a plus b. Whatever the length of a and b is, that's the runtime. Because we're going through each one of them once. So we have a runtime of a plus b. Doing a different color so we don't get confused. We have the runtime is a plus b. Which we know, since we are dividing the array in half each time, that's going to be just the whole array. We're going to go once through the array. What about this part on the top? What about the merge sort part? So if we represent this function in terms of time complexity, so we know is the time it's gonna take to run this function. It will depend on the size of the array. Yeah. So what we are doing? So we are doing some constant time operations here. All right. So regardless of the size, this is always gonna perform the same. So let's call some constant c, going to perform some operation c, and then this is gonna do something different. This is gonna divide the array in half, and then it's going to merge it. So we have, right, this is a constant, and then here is the interesting part. We don't concern about that. It will be O1. And then in here we divided the array length a by 2, right? And then we divided by 2, and then we merge it, right? We merge it, and we know that takes n. So let's say that we have some constant time and n, right? So if we take that expression, we will have that the merge sort and combine, we have the time in function of n will be 2 times the 2 times that we divided the array in half, and then the time it took to merge it, right? That's the time it took to merge it. So that's the time complexity of the merge sort. But how do we get from this to n log n? So for that we can use different methods. We could use the master method displayed in the post, or we could use substitution and see what is the pattern to see which one is the term growing. So let's use substitution to solve this. So we see we have here, we are going to do some substitution. It will look weird first, but it will make sense later. So you see that we have tm by 2. So let's replace that and see what it will be equal, that expression. So what I'm going to do, this is our base formula, and wherever we have n, we're going to replace it by n divided by 2. So n divided by 2 will be equal to 2, then we have 10, and then this will be n by 2, and since it's divided by 2 again, it will be n divided by 4, plus this n will be cn divided by 2. So now we have n divided by 4. So let's do the same. Let's replace whatever we have on n on the base formula divided by n by 4. Let's see what we get. So tn by 4 is equal to 2 t, and then we have n by 4 times 2 will be n by 8, and then we have c n by 4, right? So now let's replace these two formula into this one. It's 2 times. So this Tn is equal to 2, and now we're going to do the brackets, so we can replace the whole expression Tn divided by 2 for this whole expression. So we have 2 Tn by 4 plus Tn by 2. Now it's equal to Cn. So let's simplify this. Let's call this 1, call this 2, let's call, let's use different colors. So let's say this is the formula 1, we have the formula 2, this is the formula 3. So we have 1 in, it will be 2 in 1, 2 in 1. So we expanded this term in here using the formula 2. Okay, so now let's simplify it. Let's use the same color that we have here, and then this will become 4. We have 10 n by 4, then we have 2. It gets cancelled out because it's divided by 2. So we have Cm plus Cn. So this will be equal to 4 T n by 4 plus 2 Cn. Okay, so that's the expression that we get, 2 in 1. So now we got this formula. So now we have the definition of 4. Okay, so now let's plug 3 in 4, and let's see what we get. So that will be equal to, so we're going to expand this piece in here. So we have 4, and then we're going to open that, and we have 2t, this whole thing here, and divided by 8 plus Cn by 4, right, and then plus 2Cn. All right, so now let's simplify this. 2, that's 8 Tn by 8 plus 4 gets cancelled out, so we have Cn plus 2Cn. So if we add the summation here, we have 8 Tn by 8 plus 3Cn. Nice. So that's the formula that we have. So we could keep going. We could define what is Tn by 8. Can do it here and then replace it again, but you get the idea. So the idea is that, as you can see, let's see the pattern here. We are interested in see how it's growing. So let's see how it's growing. So it was 2, then it became 4, then became 8. So as you can see, it's growing by a factor of power of 2. So let's call it 2 to the k. Yeah. Then we have this expression, and also this number is growing by the same, n by 8, n by 4, n by 2. So every time is power of 2. So we know the next time will be probably 16 tn divided by 16 plus, and this one is growing by 1. Going 1, 2, 3, so probably the next one will be 4. So let's generalize it here. So we have n to k, and then we have k cn. And this is our generalized formula, right? Again, this is the part we are splitting the array in half and half, and then this is the merge part. So let's assume that n is equal to 2k. We are interested in knowing what's this. So for that equality, we do log n on both sides. So we have log base n of n is equal to log 2 of 2k. So if you don't remember logarithm, I mean, what it means is you're trying to find, so this is the base and this is the result, and you're trying to find what number you have to elevate the number to. So when you have the same base as the logarithm elevated, that's become only k. So we have this is equal to k. So k is equal to log 2 of n. And now let's replace that. Let's replace, so we have the t of n that we have on the top. Let's put it in red. T of n is equal to what? So we have 2 elevated to k, and k we know is log n, and then we have tn, 2 elevated at log n, both are base 2, plus we have kc, and then we have that k is equal to log 2 of n, right, by cn. So what do we have here? So 2 and 2 elevated to log of 2, it will be n. We have n, and then we have t of n, and then these 2 cancel it out, and then we have n. Let me move up a little bit so we have some more space, and then plus, we can move this term to the front so it makes more sense, log 2 of n. So we know this is 1, n by n will be 1. So we have this is equal to n t of 1 plus tn log 2 of n. All right, so what do we have here? So if we apply big O notation, what it means is we have to see which term is growing the fastest. So here is growing n, and here is growing n multiplied by log 2 of n. So this term, when n becomes sufficiently big, this term will be less and less significant, and then the whole expression will just will be dominated by n log n base 2. And then, my friends, that's why merge sort is n log n